Welcome to Maths with EJD. In this video, I'm still talking about applications of binomial series. This time around, the focus is on finance and engineering. Okay, so um, we can see that the binomial series is widely used to model economic growth. So it's used to model economic growth. It can also be used to model compound interest, and even engineering problems. Okay, so let's start with financial models. Financial financial models. So imagine that for small interests, for small interest rates are, okay, the compound interest, the compound interest formula, compound interest formula, um, which is 1 plus r raised to power n, can be approximated as 1 plus r raised to power n. Of course, different methods. We can use the formula, the binomial formula. We can also use the general formula for fractional powers or negative powers, right? And that is just going to end up being something like 1 plus nr, okay, plus n into n minus 1 all over 2 r squared. Okay, that's what that is going to be. Okay, so we can now use this. Of course, I mean, how we got there, you already should have an idea. That is simply by saying 1 raised to power n, r raised to power 0 over 0 factorial plus n now comes down, this power n into, then you now have 1 raised to power n minus 1, r raised to power 1, because n minus 1 plus 1 should always give us that n. Okay, and this time is all over 1 factorial plus this n now multiplied by this power n up here into 1 raised to power n, 1 raised to power n minus 2 into r raised to power 2 all over 2 factorial. So if you tidy all of this up, you see that 1 raised to power n is 1, 0, r raised to power 0 is 0, 0 factorial is 1. So that's why we have this one. Then 1 raised by n minus 1 is 1. So this is r raised by 1. So you have nr over 1 factorial. That's why you have this. And next you have n minus 1. Then r squared. This is 1, of course. And this 2 factorial is up here. So that's why you exactly have this situation up there. Okay. So we can now have an example where we approximate. Okay. So we can now say want to we can now have an example, right? Example. So imagine now that we want to the compound interest is 2%. So we can now need to approximate something like 1 plus 0.02 raised to power 5. So you want to approximate that for 5 years. We want to see the compound interest this will give you for 5 years. So we can basically use the binomial expansion. Since we have all the expression ready, so we can just say we have 1 plus 0.02 raised to power 5 is approximately, the first term is 1 plus n is 5, right? So we have 5. The compound interest is 0.02. Okay. The next we have 5 into 5 minus 1, that's 4. Then we have r squared. This is 0.02 squared. You can see it's really small. Then all that divided by 2. So if we tidy up all of that, this is 1. And here now this is 0.1. Then if you do all of this, this is 20. So this is 2, this is 10 here. And this is multiplied by 0. So 2 times 2 is 4. And there's 4 decimal places, 0.004, something like this. So at the end of the day, this is just So you move 1 0. Is this correct? One, two. This is it 0.0? Yeah, it's 0.02. So if you move now, um multiply this by 10, this is 0.004. Shouldn't that be? Yep, I think so. Yeah, 0.02. 2 times 2 is 4. So four decimal places now. 1, 2, 3, 4. So this is going to be something like 0.004. Okay, 0.004. Because 10, if 10 multiplies this like this, so this is just by the way. So you have three decimal places for that now. And what do you get? Um, 5 times 420 divided by 210, yeah. Then yeah, R. Okay, it's more like 2 times 10 raised by minus 2 squared. So that's 4 times 10 raised by minus 4. Yeah, we are good. So this is approximately 1.104 like that. Yeah, 1.104 because this is 1.123. Then this is 0.100 and this is 0.004. So this is 1.104. Yeah, so that is exactly what we get right there. So we can have that kind of approximation going on right there. Okay, so let's take another example that comes up in circuit analysis in engineering. So we are talking about applications in finance and engineering now. So we talk about circuit analysis, circuit analysis in engineering. Okay. So we know that in electrical engineering, the binomial series helps linearize, just like we saw in fluid mechanics too. So it helps linearize responses, responses in AC circuits, in AC circuits, or capacitor discharge equations for small perturbations. So usually when things are very small like that, binomial expansion helps a lot for small perturbations. So for imagine for example that you have 1 plus delta raised to power n. Of course, that's approximately 1 plus n delta. We've seen this kind of thing a lot of times. So for example, 1 plus delta raised to power n, right? Which is approximately 1 plus n delta, actually simplifies. So this simplifies small deviations, small deviations in circuit parameters, in circuit parameters. Okay. So in all, right, we see that by breaking by breaking problems, by breaking problems into simpler parts using the binomial series, so we see that these applications provide quick and reliable approximations, quick and reliable approximations in various fields. Okay. So we come to the end. So I come to the end of this whole series on applications of binomial series. Right. So if you have not subscribed to this channel, and of course, binomial series are not ended. There are other things I still like to talk about. Like there are still some very smart things we can do with binomial series. So if you have not signed up to this channel, please do that. Subscribe right away. Hit the notification bell so you can always get alerted each time a new video is released. And comment. Let me know how these videos have been helpful to you. All right. And then, of course, let me know if you have problems you like me to solve or topics you like me to teach like that. And of course, like and share so that more people can have access to this great content. Till I come your way again, keep doing maths right. Bye.